Hello everyone. Let's talk about types of non-decimal numbers. Now, it's important to know that we have different types of numbers that we work with in number theory. Now, this is going to be kind of a basic introduction, but the point of what I'm trying to get across here is just the methodology and understanding that number theory is really just a number of principles that you have to become familiar with and you have to kind of be comfortable with. So we're going to start just kind of developing that methodology with something really simple. First, let me start with natural numbers. Now, natural numbers are anything that exists in nature, things that you can actually count, right? And think about the things that you can count. You can only count full things. Like, for example, if I look out the window, I can see 1 car, 2 cars, 3 cars, 4 cars. I don't see 3.5 cars or 2.5 cars generally. So when I look at something that I can count in nature, we denote that by n. N stands for a natural number. And we'll put in the brace here, an open brace, for the set. So natural numbers are 1, 2, 3, all the way to infinity. Notice there's no 0 in there. 0 is not a natural number. So you can't see 0 of something. Actually, you can see 0 of an infinity number of things. But that's a whole different thing. So natural numbers are written as following, where we have an n equals, and then we put in the set of all natural numbers. Okay, so anyway, very simple principle to understand. That is a natural number. Now we also have the second kind of non-decimal number I'm going to talk about today is a whole number. Now a whole number actually includes 0 for reasons that you'll find out when you keep going with number theory. Whole numbers are different than natural numbers because whole numbers aren't necessarily things you can count in nature. Again, for us, our purposes, we have, well, here I have whole numbers denoted as a capital W, and I'll put in the set in here. For our purposes, whole numbers are natural numbers with a 0, but it's actually more complex than that because a whole number, we need whole numbers to perform arithmetic and also to have some sort of a denotion of absence of a value. So we add the 0 in there. So whole numbers and natural numbers are really different, but they are the same insofar as we're not using any decimals. So the whole number set would be denoted like this. Whole numbers equals, and notice I have a 0 in there. Now, the next kind of number is called an integer. Now, integers are natural numbers that also include 0 and all of my negatives. And integers are denoted by a z or z. So basically, integers are my numbers that start out with 0 and go to the right, 1, 2, 3, 4, 5, all the way to infinity or whatever. And then we could go backwards all the way again, -1, -2, -3, and so on. Now, there's going to be a reason why we do this. We haven't talked about imaginary numbers yet, but let's talk about integers here. Now, think about the properties of these numbers and how they kind of relate to each other. I mean, we have, like, natural numbers are things that we can count. I mean, but in an integer, I mean, we have all of our negatives. We can't count -1 of something, -2 of something, and -3. So integers aren't necessarily natural numbers, but all natural numbers are integers. And this all has to do with how we can use numbers and what we do and how we use them to describe either equations or the world around us. So integers I can put as this. I can say z, which is z, equals, and I could put in the set near all of my numbers from 0 going positive to infinity, then going negative to infinity. Now remember that integers aren't, they're not something that we could actually quantify all the time. For example, we may have integers that might require us to have a negative value. Like, for example, if we have $1 and we need to spend 10, that would be -9. But the -9 isn't something that can naturally be observed. So that -9 is not a natural number and it's not a whole number. Now, this sounds like a lot of gobbledygook, to use a technical phrase, and it also sounds maybe it's like a little bit more complicated terms that, that doesn't really need to be here. But get used to that in number theory. These are very simple principles. And once you understand simple principles, you could go on a little bit more and do more and more complex things. It all depends on your understanding and you putting the algorithm together. So what I have here is I have just a simple Python program that I wrote, and it's very simple. All this is going to do is it's going to show me all of the natural numbers from 1 to, and then n from however many natural numbers I want to go up. A very simple program. I'm just showing you that we could use software, in this case Python, to enforce algorithms. Like our algorithm here would be to print all the natural numbers from 1 to whatever. Now, in real life, we can build programs and write software and engineer software that are more complicated, but the concept is the same. You have your algorithm. Our algorithm here is to write all of our natural numbers from 1 to whatever. And then you write the code to implement that. So I was going to put in number 10 when I execute it, and notice it lists all the natural numbers. Now, what you could do from here is you could, if you wanted to, is you could write, like for example, a program to determine if a number is a natural number or an integer or what have you. But this is just a simple illustration. That's all I had for you today. I bid you all a very well rest of the day. Thank you.